Welcome to this video supporting Chapter 6 of my iOS7 Development for Absolute Beginners book. In this video, we're going to be looking at Chapter 6 of the book and some of the concepts around debugging iOS7 apps. So we'll do this by creating a very simple app for a Magic 8-Ball game, and we'll see some scenarios where we debug that app. So I'm going to start by creating the project, as I always do. Let me just resize the windows so that we can see it. I'm going to create it as a single view application. I'm going to call it Magic 8-Ball Video. Organization name, company identifier, you can put whatever you like in here. Just make sure your class prefix is empty and that your device is set for iPhone. I'm going to press next, and then on my desktop I'm going to save it on my desktop and just make sure that my source control for create git repository box is unchecked, and I'm going to create. So the Magic 8-Ball is going to be very, very simple, where we press a button, we ask a question, we press a button, and then the Magic 8-Ball gives us a random answer to that question. So we want to ask questions like that would be yes or no style answers. So what I'm going to do is go up here, and first of all on my UI I'm going to create a button, and the button, just put it on here, make it a little larger, center it, and change its caption to ask the 8-ball. And then I'm going to put a label, and the label here should read something like your answer is colon, and then I can center it again. And again, these blue guidelines are really useful for centering. Then I'm going to add another label. I'm going to make this one nice and big because the answer might be quite long, something like so. And I'll center the text on the label. So that's it, very simple, and just straightforward. We're going to press the button, we ask a question to the air, we press the button, and then the answer will come up. So the next thing I'm going to do is just to wire up the user interface by adding the outlet for the label and adding an action for the button. If you're not familiar with doing this, I'm going to be going through it quite quickly, but go back to previous videos or read through previous chapters and you'll see some more detail on this. So first of all, let's create the outlet for the label. Again, control drag to create the outlet, and I'm going to call that LBL output, like so. And then I'm going to create an action for the button. I'm going to control drag it, create an action. It's on the touch up inside event, and I'm going to call that, I don't know, button ask, something along those lines. Okay, so now I have created my UI. I'm going to press the button, and that's going to trigger the button ask function, and then in the button ask function I'm going to do something to the label, and I can, for example, just to test it, LBL output dot text equals success, just as a little test for now. We'll put the Magic 8-Ball stuff in a moment. And anybody see the bug? Yep, I forgot to put an @ here for @success. And if I run this, we should see very simple application's going to run. I'm going to ask the 8-ball, and the label changes to success. Great. We're in good shape. All right, so next let's start adding the stuff for the Magic 8-Ball itself. Okay, so first of all, the Magic 8-Ball has about 20 different answers that it can give, and it gives them at random. So we need some way to be able to store those 20 answers. And we do that in programming, and one way of doing it is using something called an array. And in Objective-C, there's this thing called an NS mutable array. NS stands for Next Step, which was a company owned by Steve Jobs before he went back to Apple, and you start to see NS turning up in lots of places as you're programming. And so NS mutable array, and I'm just going to call it magic strings. So I've created this array called magic strings, and this array is going to store all of my answers. So let's create a little function that will load all the potential answers into that. So I'm going to say void, whoops, I should put that in brackets. It doesn't need to return anything, so I call it a void, and I'm going to call it initialize strings. And so a void initialize strings is going to, the first thing it needs to do is, I've said here, look, I've got this array that's called magic strings, but I haven't given it a size yet. So the first thing I need to do is give it a size, and I do that by a process called allocation. So I say NS mutable array, I'm going to allocate a new MNS mutable array. And I'm going to initialize it with a capacity, and it has this init with capacity. And because I have 20 strings in there, I give that the 20 parameter. So magic strings, I'm just going to say, is a new mutable array. I'm allocating one out of memory. I'm initializing it with a capacity of 20. So now I want to load it up. So I'm going to say something like magic strings at 0. And remember, in computer terms, everything starts counting at 0. It would be something like it is certain. And then magic strings at 1. So the second entry is magic strings at 1 equals it is decidedly so, and so on. And just to save a little bit of time in the video, I'm just going to copy and paste the rest in, so that if we have 20 of them, they're going to be numbered 0 through 19. And there they are. So this is all of the potential strings, all the potential answers that the magic 8-ball can give us back. Okay, so next, what we need to do is we want to pick one of these at random, right? So how are we going to do that? So in the C language upon which Objective-C is based, there's this function called arc_random_uniform, which is perfect for this task. It's a little bit of a mouthful, but it's a really useful function because you give it a number and it'll return a random number between 0 and that number minus 1. So for example, we've got 20 potential answers. So if we pass 20 to arc_random_uniform, then we will get back a number between 0 and 19, which is perfect because our strings are addressed from 0 to 19. So within my button ask function, I'm going to go in here and going to get rid of this for the moment. And I'm just going to say int r equals arc_random_uniform. This guy, arc_random_uniform, and I'm going to tell it 20, like so. So my int r is set to arc_random_uniform of 20, so it's going to be a random number between 0 and 19. So now I can say lbl output.text equals magic strings at r. So I've picked one from 0 to 19, and I'm going to set lbl output.text to that. I've spelled lbl output wrong, so I get that little red underline indicating as such. So now when I press the button, it's going to pick a random string, and it's going to output and put it into magic strings, and we should get an answer. So let's give it a try and see what happens. So I now have the question, ask the 8-ball, your answer is something. I'll ask myself a question like, say, is this video really good? And I'll click ask the 8-ball, and nothing happened. Actually, it emptied my string. I'll ask it again and again and again and again, and nothing happened. Well, why? There's something wrong here, right? So how do we find out? The program hasn't crashed, and I have a bug obviously somehow causing my program not to behave properly. So how do I figure that out? Well, let's go back and we say, well, we know that the button ask isn't working right, and it looks right. So I'm saying int r equals arc_random_uniform, and lbl output.text is magic strings at r, and here are my magic strings. So what could possibly be wrong? Well, one of the things I can do is put something called a breakpoint on this line, because this line seems to be what's misbehaving, right? It should be setting the label, and it's not. So if I put a breakpoint on here, whenever I run the program, once the program reaches this line as it's executing, it's going to stop, and it's going to allow me to look at its internals and see what's going on. So why don't we do that? Why don't we run? And then we'll ask the 8-ball, and now it's going to stop. It's going to come over here, and we see this little green line now. It's telling us that the program is executing, and it's on this part here. So why don't we come in and take a look? And well, first of all, let's have a look at R. If I hover over R with my mouse, this little hint pops up and says 16. That means R at this moment in time is 16. And we have a magic string 16, which says my reply is no. So it should be working. And so now lbl output.text is magic strings at r. So why don't we take a look at what magic strings at r is? And wait a second, we can look here and say magic strings is nil. It's empty. What's going on? We have a function here that's initializing magic strings and it's setting everything up, but magic strings is empty. Well, why is magic strings empty? And then here's where you slap yourself on the forehead with your palm and you go, I have the function, but I never actually called it. Ah, there's my problem. You see, magic strings is completely empty because when we look at our execution, The view loads and it does all its stuff, and the function's sitting here completely uncalled. So why don't I stop and then call the function? And I guess the best place that would make sense to call the function would be in the view load. So in the view load, I have this function called initialize string. And if you remember in earlier videos, we were talking about the word self, and self corresponds to the view itself. So I can say self and call a function on self, which is initialize strings. Actually, I just called it initialize string. Never mind. So now that's going to call this initialize string function, and let's see what happens now if we run the application again. So I'm going to ask the 8-ball, is this video any good? I'm going to press the button. I'm going to have a breakpoint here. Now OR is set to 7. If I go and take a look at magic strings has 20 objects in it. I can drop this list down, or I can do it over here. And we can see that there are 20 objects within that. I'm not sure why the drop down isn't working right now. But we know there's 20 objects in there, and we know that number 7 is outlook good. So I can continue. And one little thing that trips up a lot of developers, me included most of the time, you think you continue by pressing this button. This button actually stops and recompiles and starts again. You see, build and run the current scheme. To continue, you go down to this little tool here. This guy will continue the program from the current execution, and these ones are used for stepping over the program. They're really useful too, as you need to debug through different lines. So I'm going to press this one to continue and go back to my simulator, and we'll see now the answer is outlook is good. And if I come in here and I can delete my breakpoint and go back to the app and keep pressing it, and now we get all the different answers. Right, so I can say, is this video good now? You may rely on it. So there we go. That's one way that we can debug applications, and it's a lot of the times your application doesn't crash, doesn't fail. It looks like nothing is going wrong. It's very, very hard to find a place where the application went wrong. So using breakpoints and being able to inspect variables and that kind of thing is very, very useful for that. So in the next section, let's take a look at a different type of bug, and in this case we'll take a look at a bug that actually causes your application to crash. So to do that, let's stop the application from running, and let's go in here and say, we have 20 possible strings for our response, but what if we had a typo here where we picked a random number between 0 and 199 instead of 0 and 19 by just typing an extra 0 on here. So that as we're developing this, we type that in, we didn't recognize it, and then we run the application. And then we ask a question, is this bug going to crash my app? Boom, it crashes. And we get this weird break. We didn't put a breakpoint on here, but what's happening is that the program has broken here to let us know this SIG-ABORT, a signal that the program has aborted, has jumped up to say this is a crash. So if the user was running this outside of your IDE, the program would just vanish and go away. It gets aborted and it's a crash. So in order to find out where it crashed, if we look on the bottom here, we have this thing called a stack call, or a call stack, and the call stack will show us like what's been going on in the application from all the way up as from core foundation, from the foundation of the operating system itself. And most of this probably doesn't look very familiar to you. But once we reach here, we see, view controller button ask. That looks familiar because that's mine. That's something that I wrote. So when I pressed button ask, something happened. Well, what was the next thing to happen was that, we have an object that's selecting something using another object. And that kind of looks familiar. Okay, and here's where things, where I have control over something, where something started to go wrong. Now, how does that look familiar? If I go back to my code and look at the view controller itself. Here we have an object, LBL output, and there's a parameter of that object, so we're doing being set to something, and that something is a selection from another object. And that kind of looks like perform selector with object with object. So it's like, maybe something has gone wrong here. So have I done something here that would crash the program? It's a little bit different from earlier where, just nothing happened. So this has given me a clue to where the program crashed, and I also, if I go back here, I can see it was in the button ask function. So something happened immediately after button ask, and there's a selector going on. That gives me a really nice clue as to what the cause of the crash is. So if I come down here, I'm going to place a breakpoint on here again, and this time I'm going to stop the app and I'm going to restart it. and I'm going to press ask the 8-ball, and I'll say, okay, I'm in here now. It looks like everything is looking good. I haven't crashed yet. Let's see what magic strings, let's see what R is going to be. Right now R is 0, so magic strings at 0, it is certain. Well, that looks good, so why don't I continue running the application? And it says it is certain. Okay, it hasn't crashed yet. So let me press the button again. Maybe it's I have to press it 2 or 3 times before the bug comes up. And I'll say, okay, what's R? And now R is 146. And now I can go, wait a second, LBL output.text equals magic strings 146. There's no magic strings 146, so the iOS gets confused when you tell it to set it to something like that, because that just doesn't exist. And if I try to continue, we'll see the crash, or even if I step over, boom, we're into the crash. So now we know that was the line that caused the error, and that line caused the error because R was 146. R should never be 146. So now it helps us zoom down to the actual line where the error is. So I go, why is R being set to 146? And I'll go, aha! I have 200 here instead of 20. So if I type 20, obviously that crashing bug will go away. So that's a very simple scenario of handling a runtime. Excuse me. That's a very simple scenario of handling a runtime error, and using the call stack and using the debugging tools to show you how to do that. Some great little tools within Objective-C and within Xcode that will allow you to find your errors like this. So let's take a look at the last type of error, and the last type of error is compile time errors. So here's where the first error was where your program ran and it didn't do what you wanted. The second time was your program ran, but it crashed because something was wrong. But then the third type of bug and the third type of error, of course, is your program won't even run to begin with. So let's take a look at that. So we'll introduce some deliberate coding errors here. So I'm going to go back into the button ask function and just put a couple of errors like arc for randoms instead of arc for random. And instead of a 2.0, I have a 2.0. And let's misspell LBL output. LBL, I'll call it outtop.text. And when I try to run my application, say I've ignored all that stuff, I see the build failed. And it gives me this one warning and these 2 errors. And if I click on this and go in and take a look, and I can also do that by clicking this icon, now I can see these details of my errors. So move the assistant out of the way so we can see a little bit more. So it's like, we got a number of different problems here. We've got the semantic issue, which is an implicit declaration of arc for randoms uniform. I don't know what that means, but I'll come back to that in a moment. Here's the obvious one. Lexical or preprocessor issue, invalid suffix O on integer constant. So it knows that this is supposed to be an integer within the brackets like this, or maybe a string, or maybe some kind of a constant, but nothing in here looks right. It's guessing it's an integer because I started with a 2. And I'd look at that and it's like, there's an invalid suffix O. What's 2O actually mean? I have no idea, but I know that looks wrong. And that's going to give me a hint right away that this should be a number. So even if I get rid of that 2, if I get rid of that O, so it's just 2, we see the bug goes away. Now obviously this is wrong because I'm just going to be picking from 0 to 2, so it'll either be 0 or 1 coming out. But the bug, the crashing bug, has gone away because of how Xcode gave me a hint for what was wrong, and that allowed me to type the right code. I'll just go and change that back to 2.0. And now there's this other one. Use of undeclared identifier LBL outtop. Did you mean LBL output? So it was actually smart enough to say, this looks like a misspelling of something that I'm familiar with. There is nothing in my system called LBL outtop, but I do have something called LBL output. You sure that's what you want to use? And I go, good catch, good find. And I can double click on fix it, and it actually fixes it for me. So that bug has gone away. And now there's this bizarre one, this implicit declaration of function arc for randoms uniform is invalid. My hint for this kind of thing is look at the word implicit. So usually when you have a function, it's either built in to the code or it's an explicit function, as in it's something that you've defined yourself, the way we've defined initialize string. Now here it's saying I can't find this function arc for randoms uniform, so you must have declared it implicitly, and you know what, that's invalid. I have no idea what that means. So you either have to write a function called arc for randoms uniform, or you've misspelled an actual function that comes from somewhere else. And I go, I wonder what it could be. I'd go back to my documentation, take a look, how do I do a random number? And I go, silly me, it's arc for random, not arc for randoms. And when I change it now, the error goes away. So again, this was now you saw my build failed, so now if I run it, I fixed all those 3 errors, the build succeeds, and I'm able to run my application again. I put the breakpoint on here earlier, which is why that happens. And actually, one other thing that I want to show, not in with the debug scenario, but I'm going to delete this breakpoint. But one very useful thing that you can do is when you've got a lot of code in a function, you can step through that code little by little. So if I run it again, now if you remember on the view did load, I have self-initialized string. So self-initialized string has been called. So now we can see my code is executing here. I have my magic strings array is set up, and but only one object has been put into it so far. And if I press this little guy here, that actually steps the line of execution, and I keep stepping, and we can see how magic strings is now growing as I step. So earlier on when we were debugging, we put like the breakpoint on this line, and it allowed us to guess because it was a very short function. But if you imagine you have a function with hundreds of lines in it, sometimes you might have to step through and look at each line little by little by little by little until you figure out what's actually going on. And that's what this stepping is for. Very, very useful. And in fact, it's almost the most useful thing that you'll have as trying to figure out what the problems are in your programs, is to step through, inspect the variables, take another step, inspect the variables, and continue until you figure out what it is that has gone wrong in your application. So there's a quick tour of some debugging within Objective-C and some of the things that are available to you. So we saw how to take a look at if the program doesn't work as expected, take a look at what happens if the program crashes, and then finally take a look at some of the things that help us to compile the program to begin with if it doesn't run because of errors. So thank you, and see you in Chapter 7.